Yes, hi. Thanks very much, Dheeraj, for that very eye-opening presentation. And um, of course, it was a great presentation on upskilling. And I would, of course, like to thank all of you for joining us here for this session again. And as you mentioned, if you do have any questions, you may always feel free to type it in the chat box, and they'll be answered perhaps at the end of the presentations. And we'd like to move on to our next session now, and this is our final session for today, where I'll be calling on Mr. Cameron Townshend. So Cameron is the solutions architect from Sonatype, and Sonatype helps software development teams use open source so that they can innovate faster and automatically control risks. So of course, the adoption of open source and software development has grown exponentially over the past decade, and yet the time required for hackers to exploit a newly disclosed open source vulnerability has shrunk by 93.5%. So of course, here Cameron will be discussing the rise of next generation software supply chain attacks. So I will leave that over to you, Cameron.
Thank you. Can you hear me okay? I'm just switching over my screen now.
Yes, we can hear you good.
Great, thanks. Okay. Yeah, so thanks everyone. So I wanted to actually speak a little bit about some of the things that Dheeraj spoke about, because we've actually seen a lot of what his research is finding in our work in open source. And one of the great pieces of innovation in the last 20 years is this growth of open source, and also the growth of DevOps at the same time. And interestingly enough, we're also seeing hackers take advantage of DevOps, and we're seeing the speed with which attackers can actually target your environment is actually accelerating. I'm going to show you how that's happened, and I'm going to show you some of the things you can do to mitigate that. And that's what we do at Sonatype. So what we're seeing is this idea of the next generation software supply chain attack, which is very similar to the value stream management that Dheeraj was speaking about from a DevOps point of view, this idea of software supply chain. So the first thing that we need to know is that established leaders are under attack. That's businesses. So since the year 2000, 52% of the Fortune 500 companies have been replaced. So what does that mean? That means for the people on this call, 50% of us are working for organizations that didn't even exist 10 years ago, or may not exist in 10 years' time. All of us are being disrupted. And so we need to be aware that that's being done at the business level, and our business leaders that we work with are being challenged all the time. And software is actually driving a lot of that disruption and innovation. So there's a hyper-competitive market out there. And the companies that we work for are being disrupted by new participants in the industry. So to remain competitive, to increase revenue, and to create new markets, we need to have these digital transformations. Organizations need to be delivering new products and services more quickly to be able to respond to their competition. No longer can they just sit back and wait. They have to actually be proactive, and software is driving that. Now, the way that software is being built, the software development lifecycle, has changed dramatically over the last 5 to 10 years. And this person here, Edward Stemming, he was responsible for helping the auto industry in Japan change the way they made cars after the Second World War. So with making a car, in the early days, cars were made by coach builders, people who made horses and buggies for horse-drawn buggies. And they started making cars, and it was a handmade artistic process. And software development was very much like that. It was like a thing that artists did, and it was a work of art. And with the car making, the idea became, though, you have to actually automate. You can't rely on inspection. You can't rely on QA processes, quality assurance processes, at the end of a car making process. That's too slow. You have to actually embed quality into every process in the organization when you're making a car to make sure that you have a good quality car. And this revolutionized car manufacturing. We're seeing the same thing with software development, where teams have to automate. They can no longer rely on manual processes. It's just not possible with the level of scale that we're seeing in software development. So the biggest trend that we've seen is this idea of a software supply chain or a value stream management that Diraj was talking about. They're very much the same thing, where software is actually constructed, firstly, from a huge amount of open source components. Secondly, source code, the code that's actually written in-house by your developers. Then that software is packaged up into containers and then deployed as infrastructure as code. And this entire process is automated from start to finish. Now, this is great. This allows you to innovate very quickly, but it introduces a lot of risks. And I'm going to show you what they are. So first thing to notice is that a modern application, this is according to research from Gartner, is over 90% comprised of open source software components. So what that means is that your software that you're running in your DevOps pipeline is mostly sourced from third parties. You don't even know who they are. You're bringing in third-party libraries from these open source developers, and you're trusting them. The other problem too is that there's 21,000 new versions of open source libraries released every day. This is across the major ecosystems such as Docker, NPM, Maven, which is the Java one. Across all these different systems, there's thousands of new versions every day. It's not possible to manually check all of these things. It's very important that you have an automated process that you're checking these libraries before they come into your pipeline. Next, you have your source code, and speed is king here. Developers want to release more quickly. What we're seeing is the release frequency of DevOps team has increased 208 times more quickly than in the past. So, I'm probably a bit older than everybody on the call, and I used to work for the world's largest insurance or reinsurance company, and we would release twice a year. And both of those releases didn't go very well because they were done manually, and we weren't very good at releasing because we had very, very slow manual processes with lots of approvals. Modern teams don't do that. Modern teams such as Facebook and these other organizations release thousands of times a day, and they do it through automation. One of the key innovations was this idea of containers. And again, Gartner reported that by 2022, that's just next year, 75% of global organizations will be running containerized applications in production. This is the growth of microservices. So again, Diraj was talking about these massive legacy systems and huge amount of technical debt that organizations have. That's slowing them down because to do a release, you have to release everything all at once. Very, very hard to release or to scale bits of your infrastructure. The other speaker, Mark, was talking about APIs. If you use a containerized approach with microservices, you can actually release the APIs very quickly and you can scale them very quickly. So as demand increases for a particular service, containers can be automatically load balanced using tools like Kubernetes to deploy containers rapidly to meet that demand. Then as that demand goes away, those containers, those clusters can actually be shut down and return your resources back to the pool. So you're not paying too much money for underutilized infrastructure. It's a massive, very, very important innovation, and I'm sure all of you are aware of. Again, can only be done with automation. You have to automate everything to allow you to run containers effectively. The final piece of the puzzle is infrastructure as code. So by 2023, 60% of organizations will use infrastructure automation tools as part of their DevOps toolchain. And this is going to improve application deployment by 25%. And again, why is this happening? Well, traditionally, organizations were run in silos. So you would have a development group, a security group, and an operations group. And these silos would all be run by different managers, and they wouldn't collaborate with each other. And there'd be a lot of miscommunication and conflict in those groups. The growth of DevOps, one of the key things about DevOps is the growth of collaboration and communication between development teams and infrastructure teams. And infrastructure as code allows you to do that, because what can happen is if you need to do a deployment and you need to change some of your infrastructure, you can actually go back, change it in source code, and then redeploy that. And you've actually got a repeatable, reliable process for running your workloads in production. This is very different from traditional systems where they were manually maintained and manually deployed by different teams, and the developers weren't actually responsible for operations. Since infrastructure as code has come about and developers are now responsible for running their own workloads, quality goes up. Because if you're responsible for operations as a developer, you're going to make sure things work properly. Now, there's going to be challenges to all this automation and innovation. And what we've seen at Sonatype is this challenge around open source. So first thing that we run a survey, which is the DevSecOps community survey, and we also run the State of the Software Supply Chain report. These are two reports that we run. We survey over 5,000 participants each year, and you can download these reports from our website. They're freely available. In that survey response, 1 in 4 organizations reported having a breach due to an open source software library they were using. The other thing that we noticed is the 430% year-on-year growth in cyber attacks targeting open source. So the attackers are actually targeting open source. I'm going to show you a very specific example of one attack that's grown even more quickly than that. Interestingly, NPM, which is the biggest ecosystem in the world for open source libraries, recently bought by Microsoft. In that ecosystem, 40% of NPM packages rely on code with known vulnerabilities. It's very widespread. It's not a rare thing. And then 1 in 10 components that are downloaded have a known vulnerability. So this is a very, very common problem. This is not a rare problem. In fact, a lot of very famous breaches occurred because of these open source libraries, such as Equifax, and even a very famous system called Aadhaar in India, infrastructure, electricity generation. Lots of enterprises have been breached through these open source libraries recently. Now, what's the main challenge here? Well, there's a gap, this trust gap between developers and security. Developers are driven by often they're driven by project priorities. So deliver this project quickly, deliver something now, we need a feature now. Security and QA and compliance are more concerned about ongoing risk management. And so developers have a daily challenge, where security and governance teams have a longer monthly time frame. They have that sort of product mindset. And that gap causes bugs to occur. Now, let me show you an example of that. This is a particular breach, a particular style of attack called dependency confusion. Now, what happened here was the security researcher realized that package management systems such as NPM and the Python one, PyPy it's called, could accidentally download a library that was actually a malicious library in place of a real library that a company was wanting to use. And he thought, hey, what happens if I try this? And he did it, and he found that he actually could break into 35 different companies, including Microsoft, Tesla, Netflix, using this breach. Since that researcher did that, he was a white hat. He was a legitimate researcher. Many copycats have actually used this technique to break into organizations. And I'm going to show you how it occurs, what's actually going on. So this is a view of how packages are requested by developers. This is the NPM ecosystem. On the left-hand side here, I have the blue boxes. That is the internal development environment at your organization. On the right is the public repository, in this case, NPM. Now, what a developer says is, okay, I want this public package, React library, and I want this internal library called our library. Now, he says, I want the latest. So when that person does that, it says, okay, give me the latest React API. And then the NPM system goes out to the internet and sees all of these versions here. It says, oh, you're using 3.1 here. I'm going to give you the latest patch. But you can also tell React, hey, give me the latest major version or the latest minor version. So that will actually jump and get you 3.2 or 3.4 in that situation. Or you can even say, give me just the latest version. I just want the latest version. A lot of people are always told, just get the latest version. The latest version is the best. Now, there's one problem with that. The latest version could be malicious. And somebody realized, what happens if I actually publish a package that's actually greater than that? And so what they did is they said, I could publish something into version 5000. Now, that would be picked up by the community because they would see the React API. But imagine if a bad actor discovered that you had a library called our library, and this is your internal library that you use inside your organization. And so the developer's saying, give me the latest version of our library. And then the bad actor says, I'm going to publish a version of our library with a massive version number, 99999, into NPM. There's nothing to stop them from doing that. The problem is, if they were to do that, that library would actually be downloaded into your organization. And so suddenly your team would have our library 999999 inside of its code base. This is actually what happened. And so the hackers realized they could take advantage of NPM's desire to always get the latest version of the package. And by doing that, they then tricked the developers into downloading the latest version of an internal package with the same name as the one that they're using, but it was published into NPM. And developers didn't notice that. This was the attack. Let's have a look at the payload. This was a payload that was done to target Amazon. And what we're seeing here is on the left-hand side here, the folders, there's actually a package.json and a run.js. In this particular attack here, the attackers knew that they could actually run a script. So NPM is a package manager, but it's also a script runner. And as part of the installation, you can actually tell it to run scripts as part of the pre-install and post-install processes. And what this particular JavaScript file is doing here is it's actually reading the etc shadow folder, etc shadow. That is where passwords are stored on a Linux machine. And what it's actually doing here is it's actually listing out all the passwords in there and sending it to a command and control server, which is this one here. What this attack is also doing, which is also really clever, is getting the .bash history file off the developer's machine. Now, in Linux, when you're typing commands at the command prompt, the bash history is going to store all the commands you've typed in your session. One of those commands could well be logging into a server using your username and password. So by grabbing the bash history, the attacker is actually grabbing the username and password in clear text for your servers from your developers. So let's just recap what's happening here. This is a malicious payload that is actually targeting the developer. And by targeting the developer, what they're doing is they are injecting their malicious payload before the code is even deployed into a testing environment that the security team might even see. They've actually already hit the developer, and they've already actually launched their attack because they're targeting the developer. And what they're doing here is they're relying on the huge amount of trust that developers have in the ecosystems that they're downloading the libraries from. Because you've got to remember, developers by nature are very optimistic, and to some degree they're quite naive about the risks in these open source ecosystems. The other problem is that when someone publishes to an open source ecosystem, they could be a good actor or they could be a bad actor. They all look the same to your developers in your organization. And thirdly, when they do that, they're taking advantage of the trust, but also developers don't tend to be risk conscious. They tend to be more focused on delivering functionality, and they say to security, leave me alone, I'm too busy to worry about security. And so attackers are now targeting developers. And so what they're doing is they're not waiting for vulnerabilities like in the old days. They're actually injecting vulnerabilities into the development process. And that's what we're seeing a huge growth of in recent years in NPM and also PyPy and other ecosystems. So let's look at the timeline of this. In July 2020, our servers at Sonatype detected this. We actually contacted the researcher, Alex Bursan. He's a well-known researcher in security circles, and asked him what's going on here. And he said, look, I'm under a non-disclosure agreement. Don't tell anybody about it. I'm actually testing to see if organizations are going to download these packages. So we had that in our sort of backlog catalog as something to be aware of. And then on February the 9th in 2021, Alex Bursan published his very well-known article now, how he broke into these 35 companies. He actually claimed 130,000 US dollars in bug bounties. So at that time, once that became well known, other people looked at it and said, hey, that's really, really easy. The discovery was hard, but the use of the attack is very easy. So within 72 hours, we saw 300 copycats emerge. So the attack window is really narrowing now. Then 4 days later, the number of copycats increased by 7,000%. That's how quickly attackers are responding to new ways of breaking in. Now, interestingly enough, on February 22nd, other ones had broken in as well. And we're seeing a massive amount of increase. And now, by March the 15th of this year, once people realized they could do the same thing in PyPy and NPM, there's 10,000 copycats. So there's some very good articles here. If you are interested in application security and how these things actually work, and you have a development background, there's some very, very good articles. One of the tricks, for example, in PyPy is that somebody searched GitHub for all the PyPy projects that were using a particular syntax for grabbing packages, and that just gave them projects to break into. Very, very easy to do. Very, very easy to replicate this attack. So what do you do as an organization to protect yourself? Well, firstly, automation is indispensable. There's 20,000 new packages every day. As Diraj pointed out, one of the key successes for you as a professional in this industry is to be able to embrace automation. You cannot do this sort of checking manually. And that's what Sonatype can help you with. We monitor these things. We have 100+ researchers. We have AI and machine learning that are looking for these suspicious packages. We actually have a product, which is Nexus Firewall. Nexus Firewall can actually block these attacks. So you can actually have a product that will actually protect you. One of the things that you can do as an organization is register your private dependencies and your namespaces. In fact, namespace verification is a must. So namespace verification is in NPM. One of the things you can do with a package is you can preface the name of the package with a namespace, and you as an organization can own that namespace. What that means is that no one else can claim it and publish packages to your system. And by claiming that namespace, then you know that all of your libraries are going to be downloaded from that particular verified address and not from a random address. Very, very important thing. That doesn't cost you anything. You can do that inside of NPM today. Very much recommend you do that as a takeaway from my talk, as something you can do immediately. But again, yes, we do have a product that will help you to do this longer term. So let's just recap some of the things that we're seeing. So firstly, developers, they want fast code. They want feedback. They want to know if a library is vulnerable, but they don't want to do it by hand. It takes 2 to 4 hours per library to research it. You've got hundreds, if not thousands of libraries in a project. That's a lot of work. Typically, it doesn't get done. The other thing too is you want to know about your transitive dependencies. So transitive dependencies, this is also called indirect dependencies. It's basically when you bring in a library or a project, it can bring in other dependencies, and your developers may not even be aware of them. So that takes a lot of research to look up those things. And so what we want is we want a massive increase in release velocity. That's what developers want. Next is security. Security are under a lot of pressure to reduce the attack window. So as we saw, these attacks are being launched within 2 or 3 days of a discovery. If you remain unpatched for more than 3 days, it's very easy or very believable that you can be broken into through that exploit. So security are under a very tight window to patch their environment. And so what we want to do is we want a massive reduction in time spent addressing malware. That's what security want. That has to be done with automation. You've also got legal requirements as well. Some of your organizations might have a situation where you're using a library and your lawyers want to make sure that you are allowed to use that library and are not using a library that's not permissible for your organization. So again, that needs to be automated from a legal point of view. And then finally, from operations, so time spent doing pre-deployment checks. If you're going to be deploying rapidly all the time, you want automated checks to make sure you're not making mistakes with your misconfiguration, for example. Imagine you're deploying into Amazon and you open up an S3 bucket accidentally. Want to make sure you don't do that. So that can all be automated using infrastructure as code checks. So just to wrap up here and to summarize what I've been talking about, we have a software development lifecycle, and this is a new view of it, and it's looking at it like it's a factory, a software factory or a value stream. And the idea here is that you have these public repositories of open source libraries. Massive innovation there for your developers. They don't have to rewrite everything from scratch. They use the great work from people like Mark Shan and his team of very bright people who create very, very powerful APIs for you and libraries. But when you bring it into your factory, you need to check it. So this firewall will allow you to stop vulnerable libraries coming into your supply chain. You need a repository to store libraries and your build artifacts. Give you the idea of being able to promote and publish releases into your release environments. Then you need to check your legacy code as well, because you've got these legacy systems. In fact, I was at a bank and the tech lead there said, Cameron, my legacy systems drive my business. They're the most important asset that I have. They need to be protected and monitored. So that's where you need to monitor that. We have our Nexus lifecycle to monitor that, but you can also monitor the build process and the developer's view. The developer gets to see the open source libraries that they're using, make sure they're not using vulnerable libraries before it goes into the pipeline. And then also you want the ability to have actionable information on the source code that's written in-house. We can do that as well with our Sonatype left, which is giving the ability to check your custom code. We've also got Nexus Container for those container workloads. And we also have infrastructure as code. Gives you the ability to ensure that you're not misconfiguring your environment when you are running that infrastructure as code. And with that, that's my time up. Thanks for listening. Hopefully that made sense, and happy to hand it back to the floor and any questions.
Yes, hi, Cameron. Thanks for that great presentation to cap our event for today. And of course, one thing I took from that, and of course, I'll take from your presentation is that if we don't fight back, then we'll always be at the mercy of the hackers, especially during this time of COVID.
Yes.
You know, they're always evolving in ways that they have their waves of different attacks going on. You know. Yep. And I haven't seen any questions from any of the audience. Did somebody? If somebody asks for the presentation, yes, to share the presentation can be shared. We will get in contact with you. And if there are no further questions, I would just like to conclude all the sessions. That will conclude all the sessions that we've had for today. Then, and I assume nothing. And I assume nothing else will have to be shared at the moment. And right now, I would just like to thank you all for joining today. I would like to thank Forrest, Mark, Dheeraj, Dheeraj too, still on stage with us, and of course you too, Cameron. And I hope you all learned something today from all of their insightful presentations. We will be having more events. Actually, our most recent one will be taking place tomorrow. So maybe you may register using the link that I just sent in the chat box, and we'll be seeing you there. So we'll be starting at 2:30. And of course, stay tuned for our next events. And until then, stay safe and goodbye. Thank you, everybody.
Thanks, Pete. Thanks for having me. Great event.
Thank you. Bye-bye.
Thank you. Take care.
Thanks,
Bye-bye.
Dheeraj.